Hello there! Great morning, students and dear listeners. Welcome to our class on air here in DXVD 101.3 FM, the voice of the Pitan. Once again, this is teacher Sherry May from the Pitan City National High School for grade 9 science lesson for the week 2 of April 2021. Grade 9 students, are you ready? In this session, let's study geothermal energy and how this geothermal energy is harnessed in our community for the different uses. And dear students, please pay attention for today's target. Number 1, describe the different forms of geothermal power plants. Number 2, explain how geothermal power works to produce electricity. Number 3, cite the uses, advantages, and disadvantages of geothermal energy. And number 4, explain the mechanism of geothermal heat pump used as heating and cooling system. Now, let's look into the past and see how the ancient people utilized this geothermal energy. In the 1st century Anno Domini, Romans conquered Aquae Solis, England, used the hot springs there to feed public baths and underfloor heating. The admission fees for these baths probably represent the first commercial use of geothermal power. Hot springs have been used for bathing at least since Paleolithic times. The oldest known spa is a stone pool in China's Lisan Mountain, built in the Qin dynasty in the 3rd century. The world's oldest geothermal district heating system is in France, has been operating since the 14th century. The earliest industrial exploitation began in 1827 with the use of geyser steam to extract boric acid from volcanic mud in Lardy-Rillieux, Italy. In the 20th century, demand for electricity led to the consideration of geothermal power as a generating source. Prince Piero Ginori Conte tested the first geothermal power generator on the 4th of July 1904 at the same Lardy-Rillieux dry steam field where geothermal acid extraction began. It successfully lit 4 light bulbs. Later, in 1911, the world's first commercial geothermal power plant was built there. In 1960, Pacific Gas and Electric began operation of the first successful geothermal electric power plant in the United States at the geysers in California. The original turbine lasted for more than 30 years and produced 11 megawatts net power. In the Philippines, geothermal energy development was stimulated in the mid-1970s oil crisis and rapidly growing power demand. In 1962, geothermal exploration was started and the first large commercial power plant came online in 1979 in the Philippines. Leyte Island is where the first geothermal power plant has established, and a 3 megawatt wellhead unit started operations in July 1977. The larger scale commercial production of geothermal power began in 1979 with the commissioning of a 110 megawatt plant at Tiwi Field in Albay Province, Luzon. Presently, the Philippines is declared as the second largest producer of the electricity from geothermal resources, and the Philippines has 7 geothermal fields, 3 from Luzon, 2 from Visayas, and 2 from Mindanao. And the geothermal energy supplies the 12% of the nation's energy. The legal basis for the construction or establishment of this geothermal power in our country is the RA 9513, known as Renewable Energy Act of 2008. So this is an implemented law that supports the exploration and use of geothermal energy resources in our country. Why is the Philippines so rich in geothermal energy? The Philippines is one of the world's top producers of geothermal power, owing to its location along the Ring of Fire zone of Pacific volcanoes. The Ring of Fire, also referred to as the Circum-Pacific Belt, is a path along the Pacific Ocean characterized by active volcanoes and frequent earthquakes. The Ring of Fire gets its name from all the volcanoes that lie along this belt. Roughly 75% of the world's volcanoes are located here, many underwater, and this area is also a hub of seismic activity or earthquakes. 90% of the earthquakes occur in this zone. And this is the reason why the Philippines is so rich in geothermal energy, because it lies in the Ring of Fire. So, what is geothermal energy? Geothermal energy is thermal energy or heat energy generated and stored in the earth. In other words, geothermal energy is heat within the earth. The word geothermal comes from the Greek words geo means earth and thermi means heat. Geothermal energy is a renewable energy source because heat is continuously produced inside the earth. Now, what are the sources of geothermal energy in the earth? Or where does the heat within the earth come from? So, what are the sources of heat within the earth? 80% of the heat in the Earth's interior comes from the slow decay of radioactive particles in the Earth's core, a process that happens in all rocks, and this produces heat or geothermal energy. And 20% of the heat of the Earth's interior comes from the original formation of the planet. Now, what are the uses of geothermal energy? So we have 2 categories of uses. Under direct uses, geothermal energy is used for air conditioning, industrial processes, drying, in greenhouses, aquaculture, in resort and pools, and in melting snow. And for the indirect uses, geothermal energy is used in electric power generation. Now, how is geothermal energy obtained? From the geothermal reservoir. By the way, when we say geothermal reservoir, this refers to the sources of geothermal energy in the Earth's crust, which can be hot water reservoir, natural steam reservoir, geopressurized reservoir, normal geothermal gradient, hot dry rocks, and molten magma. So these are what we call sources of geothermal energy or the geothermal reservoir. Again, how is geothermal obtained in a geothermal power plant? At a geothermal power plant, wells are drilled 1 to 2 miles deep into the earth to pump steam or hot water to the surface. And then the steam spins the turbine, which is connected to a generator that produces electricity. Then the steam cools off in a cooling tower and condenses back to the water, and the cycle repeats itself. Again, there are 3 steps in obtaining geothermal energy from the geothermal reservoir. Number 1, wells are drilled 1 to 2 miles deep into the earth to pump steam or hot water to the surface. Then, number 2, the steam is piped to the turbine, and once it reaches the turbine, it spins or drives the turbine, which is connected to a generator that produces electricity. And third, the steam cools off in a cooling tower and condenses back to the water, and the cycle begins again. So as simple as that. So we can harness now geothermal energy as our source of electric power. There are 3 types of geothermal power plants. Number 1, we have the dry steam power. Number 2, the flash steam power. And number 3, the binary cycle power. The dry steam plants uses underground steam to directly turn the turbine. Here, geothermal reservoir containing pure steam is required, and this pure dry steam drives the turbine, and the generator then produces electricity. The second one is the flash steam plants. So this system pulls deep, high-pressured hot water that reaches temperatures of 360 degrees Fahrenheit or more to the surface. Then this water is then transported to low-pressure chambers, and the resulting steam drives the turbines, and the remaining water and steam are then injected back into the source from which they were taken. So, in the flash steam power plant, geothermal reservoir containing both hot water and steam is required. So again, geothermal reservoir containing both hot water and steam is required, and pressure changing system is required because we need to convert the hot water into steam in the second chamber. The third one is binary cycle plants. This system passes moderately hot geothermal water past a liquid, usually an organic liquid that has a lower boiling point. The resulting steam from the organic liquid drives the turbines, and this process does not produce any emissions, and the water temperature needed for the water is lower than the needed in the flash steam plants. So what's unique with this binary cycle power is that it does not use steam directly to rotate turbines. So we use vaporized hydrocarbons to spin the turbine. Hydrocarbons here have lower boiling point. So we use hydrocarbons such as isopentane, isobutane, and propane. And no harmful gas is emitted to the atmosphere. So, what are the advantages of geothermal energy? So, number one is it is cost saving. Geothermal energy generally involves low operation cost since it saves 80% cost over fossil fuels and no fuel is used to generate the power. Since no fuel is required, so cost for purchasing, transporting, and cleaning up plants is quite low. Number two, it reduces reliance on fossil fuels. So the use of geothermal power reduces our reliance on fossil fuels or dependence on the fossil fuel. So dependence on the fossil fuels decreases with the increase in the use of geothermal energy. With the skyrocketing prices of oil, many countries are pushing companies to adopt these clean sources of energy. Burning of fossil fuel releases greenhouse gases which are responsible for global warming. Third, the use of geothermal energy has no pollution. So this is one of the main advantages of using geothermal energy since it does not create any pollution and help in creating clean environment. So being the renewable source of energy, geothermal energy has helped in reducing global warming and pollution. Moreover, geothermal systems does not create any pollution as it reaches some gases from deep within the earth which are not very harmful to the environment. Fourth, geothermal energy has direct application, so it can be used directly. Since ancient times, people having been using this source of energy for taking bath, heating homes, preparing food, and today this is also used for direct heating of homes and offices. This makes geothermal energy cheaper and affordable. Although the initial investment is quite steep, but in the long run, with a huge cost saving, it proves quite useful. Fifth, geothermal power plants don't occupy too much space and thus help in protecting our natural environment. And lastly, unlike solar energy, this source of energy is not dependent on the weather conditions. So, what are the disadvantages? So, if there are advantages, there are also disadvantages. What are those? Okay, so we have few disadvantages. Number one, only few sites have the potential of geothermal energy. Number two, installation cost of steam power is very high. Number three, most of the sites where geothermal energy is produced are far from markets or cities where it needs to be consumed. And number four, there is always a danger of eruption of volcano. And number five, installation cost of steam power is very high. And number 6, there is a possible release of some harmful poisonous gases that can escape through the holes during the construction of the power plant. Much more than providing us electric power, geothermal energy has enabled many to heat their homes in winter, cool them in summer, and provide abundant hot water throughout the year. Now, how can this geothermal energy be tapped to perform the heating and cooling function? The answer is by installing a geothermal heat pumps. Geothermal heat pumps are technologies that leverage the nearly constant temperature below the earth to heat and cool buildings. Just a few feet underground, the earth has a constant temperature of 50 to 60 degrees Fahrenheit. The temperature below the earth is warmer than the air circulating above it during winter and cooler during summer. Unlike geothermal power, geothermal heat pumps extracts hot water several feet deep into the earth, not for the purpose of electricity production, but for the purpose of heating and cooling of buildings. Now, how does a geothermal heat pump work to heat and cool the buildings or offices or our homes? Heating and cooling is achieved through a geothermal heat pump system, which is made up of 3 main parts: the heat pump unit, the ground heat exchanger, and the air delivery system or ductwork. The heat exchanger encompasses a series of pipes known as loop, which is installed a few feet beneath the earth close to the building. Then a fluid, a combination of water and antifreeze, circulates through the series of pipes to suck up or disseminate heat into the ground. The fluid is usually blended with antifreeze to prevent freezing during winter. The working of a geothermal heat pump has a lot in common with a refrigerator. A refrigerator makes a cool place much cooler by transmitting heat to a significantly warm place, allowing it to become warmer. During winter, the geothermal heat pump extracts heat from the ground, heat exchanger, and channels it to the building's air transfer system, which keeps the house warm and comfortable. During summer, the cycle is reversed. The geothermal heat pump extracts heat from the air inside the building and transfers it into the ground heat exchanger. The heat exchanger dumps the heat into the earth. The heat extracted from inside the building in the summer can be utilized to heat water, providing homeowner free hot water throughout the year. The use of heat pump for heating and cooling function shows how geothermal energy can be used directly in our community. This is all for today, students. Thank you very much for your time. Thank you for listening. For this RBI segment, thank you, DepEd Dapitan City, headed by our Superintendent, Dr. Felix Romy Triambalo. And thank you, LGU Dapitan City, headed by Mayor Rosalina Garcia Haloshos. Grade 9 students, if you have questions in mind and would like some clarifications, please feel free to send an email, or you can follow my YouTube channel for more educational videos. Again, thank you so much. Rise and shine. Educalidad. Keep safe, everyone. Bye-bye. Rise and shine. Educalidad. Bye-bye, everyone.